reactions. One more problem, one simple problem we can solve. A roller of weight 10 kilonewton is rolling over a horizontal surface like this by applying a force of P at 30 degree with the horizontal. Its diameter is 1 meter. Diameter is 1 meter. At a particular instance, an obstacle comes across the roller. An obstacle comes across the roller and its height is 10 centimeter. So we need to find out how much force is needed for the roller, or this how much force is needed to overcome this roller. That is, what should be the magnitude of P. Direction is already given at 30 degree with the horizontal, so we need to get the magnitude of P. So if you draw the free body diagram of this roller, the roller its weight is acting vertically downwards. It is 10 kilonewton, and here the obstacle is here. So the reaction from the obstacle will be acting like this. So this is the line of action. So this is the reaction R. Okay. Let this be angle theta. So here also this angle is also theta. This angle. Okay. Now this distance is 50 centimeter because the diameter is 1 meter, 100 centimeters. So the radius will be 50 centimeter. And this distance will be, how much it will be? That is, this radius is 50. So this is 50, and the obstacle's height is 10. Therefore, the remaining distance will be 50 minus 10 equal to 40. So we have a triangle of a right angle triangle of opposite side 40. This angle is theta, and this as the hypotenuse as 50. So from this triangle, right angle triangle, sine theta equal to 40 by 50, opposite side by hypotenuse. So theta equal to sine inverse 40 by 50. Therefore theta is equal to, when you calculate this, you will get 53.13 degrees. Theta has 53.13 degrees. Now, how many forces are acting on this roller? 3 forces. And just at the point of overcoming the obstacle, just at the point of overcoming, or at the instant of overcoming the obstacle, the roller will not be touching the ground, just above the ground, and there are only 3 forces acting on the roller. That is 10 kilonewton as the weight, the reaction at 53 0.13 degrees, and the magnitude is r, that okay. Then P at 30 degree angle. So these are the three forces acting on the roller when it is just above the ground. That means just when the roller is trying to overcome the obstacle. So at that point we can say the roller is in equilibrium. It is not moving. At that particular instant, on that one instant only, the roller is in equilibrium under these three forces. So that means we can use Lami's theorem. For that we need the angles. We know this angle is 90 degree, this angle is also 90 degree, so this total angle will be, this will be 120 degrees, and this is 90 degree, this is 53.13, so this total angle will be 90 plus 53.13 means 143.13 degrees, this angle, and this is 120 degree. So this angle will be 360 minus 120 plus 143.13, that will be equal to 96.87 degrees. This is 96.87 degrees. 96.87 degrees. Okay. So we have all the angles. Now applying Lami's theorem, how we can apply? Say P divided by corresponding angle sine 143.13 is equal to, what we know is 10 divided by sine 96.87, and from this we will get P equal to 6.04 kilonewton. And if you want to find out R, if you are asked to find out R, then use the equation R by sine 120 is equal to 10 by sine 96.87, which will give you R equal to 8.72 kilonewton. So these are the answers, that is P is equal to 6.04 and R is equal to 8.72. So in this problem, what we need to consider is that when the roller is just above the ground, that is just about to overcome the obstacle, the roller will not be touching the ground, so there will not be any reaction from the ground. That means the roller is in equilibrium under the action of P, 10 and R, the forces. So we can apply, and another thing is these are in equilibrium, also they are concurrent forces, also concurrent coplanar forces. So we can apply Lami's theorem, and Lami's theorem states that if three forces are acting on a body in equilibrium, then three concurrent forces are acting in equilibrium, then each force will be proportional to the sine of the angle between the other two forces. Okay.